Hello, I'm Dennis Allen, and as a healthcare physician, I'm concerned with the quality of our food and water, and the effect the environment may have on our food and water supply. Those things that will have a direct effect on our health and well-being. A short time ago, I met a gentleman who shared my concern and who had previously been involved in the invention and development of a very unique and original water purification system, or better thought of as a liquid purification system. This system had been in production for commercial use and available in the marketplace for some years, but at the present time was not being produced. Hello, John, and thanks for sharing this important information with us.
Yes, I'm always happy to introduce the CLP system. The system utilizes flash distillation and vacuum evaporation technologies in conjunction with the liquid vapor separation system and their proprietary energy recovery process.
Does this method of purification utilize filters or chemicals?
No, this system employs a natural process, uses no filters or chemicals, nor internal moving parts to purify the liquid being processed.
Is there any pre or post treatment needed to arrive at the finished product?
No, this system requires no pre or post processing treatment.
What kind of monitoring skill level is needed to operate the system? And is it less expensive than other systems to operate?
The system is fully automated and fail-safe. It does not require continuous monitoring. It can be operated by semi-skilled personnel. It has built-in programmable emergency controls. A computer, smartphone, or tablet can remotely monitor the system. These combined factors render this system efficient, effective, and economical.
Okay, so what kind of liquids can be processed and purified with this system?
The Cellini system is capable of processing any contaminated liquid, be it sewage or chemical waste. It can also be used for desalination and in the capture and disposal of CO2.
Well, that sounds great. I have some additional questions that come to mind as you speak. One is mobility. I'm thinking of situations where a system would be very helpful and usable in locations like where they do fracking and oil exploration, etc. and a lot of water is used. Can the system be mobile and move from one location to another when a site is finished with its processing, or do they have to be stationary?
No, the Cellini system provides a range of mobile options which allow on-site treatment feasible. The systems can be arranged in tandems and placed on flatbeds and transported to the desired location. In the case of desalination, the systems will be arranged on a floating vessel and sailed to the needed location. This offshore floating arrangement eliminates the need to use large, expensive coastal land as is used by other methods in use today.
Well, that sounds great. What about capacity? Some areas of industry require huge amounts of processing, some less. Can systems be constructed and designed to meet individual needs depending on the area of industry?
The system can be adapted to a wide range of unit sizes. This technology permits Cellini LPS to produce systems as small as 30 gallons per day up to 1 million gallons per day capacity. The Cellini LPS uses all inert materials in the system's construction. No leaching, corrosion, or degradation of wetted surfaces. Rugged construction assures reliable operation in the harshest of environments. I want to thank you for allowing me to introduce the Cellini system.
And I want to thank you for giving us that information. And for those who are interested to follow up with additional information or want to make contact with us, on the screen you will see our email address, which you're welcome to contact us with. Thanks again, John. And I want to mention to our viewers that following up We're going to have some graphic representations to show additional information about the system, so please stay tuned. Once again, thank you, John Cellini.
Thank you for having me here.
Today we're going to talk a little bit about the basics of ocean chemistry and transforming seawater into pure water and some form of reusable salts. In our basic understanding, carbon dioxide, which occurs naturally in the atmosphere, when it dissolves in water, it forms carbonic acid, and then it would break down further into bicarbonate and carbonate ion. Now when it does that, and you can see from this chart, the H plus or hydrogen ion concentration would increase, thereby lowering the pH. And once we have that carbon dioxide dissolved into water, making carbonic acid, our pH is going to actually change, because as that carbonic acid releases those hydrogen ions, the pH level is going to change. And when it does that, you can see from this chart that the bicarbonate ion and the actual carbonate ion also will increase. Now what makes this interesting is that these now can react with other metals that maybe occur in water, such as sodium to make sodium bicarbonate, you know that as baking soda, or even toothpaste, things like that. So as we're increasing our bicarbonate and carbonate ion, we now can take the sodium and potassium and magnesium that naturally occur in seawater at a pretty well known concentration and react it to make usable materials such as sodium bicarbonate, again, baking soda, magnesium carbonate, things like that. And because I know essentially what the ocean concentration of minerals are, I can gauge that by altering different factors such as temperature and pressure, and I control that really by depth. So you can see from this chart here that obviously the deeper down I go in the ocean water, the temperature is going to be colder and the pressure is going to be higher. Therefore, the concentration of those minerals should be typically a little bit higher. So as you can see here, the salinity content increases as you go farther down. The potential density obviously also goes down. And because we know these factors, these are things that we can control, knowing what our known concentration is or optimum level of production for turning ocean water into not only pure water but also viable usable materials, like I said, such as baking soda, toothpaste, or whatever. And this slide actually further emphasizes the point of the prior slide, where we say at high latitudes the salt content is going to increase farther down you go, meaning that because it's cooler waters that you're going to basically have a higher concentration of salts the farther down you go. And again, those factors are because of temperature and pressure. Whereas if you go to lower latitude areas, that salt content is going to decrease the farther down you go, because the temperature increase makes things want to separate. So you're wanting to get those salts out of solution, let's say. So think of it like if I boil water, obviously the salt's going to come out quicker than if I left it cold over time. And again, yet because we understand that all ocean water essentially has the same concentration no matter the latitude that you are located, and also within the depth, we understand that the salinity ranges are going to pretty much stay the same no matter where you are. It's just going to be some form of fluctuation. So statistics show that the ocean covers 70% of our planet, and then that 97% of the Earth's water actually is found in the ocean. And so we need to have a way that's more efficient of not only converting ocean water into viable drinking water or processed water or even for irrigation for this planet, but we also need to do something with the material that's created from the desalination and use it more effectively than just creating more waste on our planet. So the aim here is that Cellini Water Systems has a very viable and effective way of not only desalinating water to be used for, again, processed water, irrigation, drinking water, but also to be able to do something with those salts and the materials that are created as a byproduct, those carbonates and those bicarbonates that we can now convert into usable materials.